Can I ask, who here has heard of DFINITY? Internet Computer Project? Cool, okay, maybe like 5%. Is everyone here into crypto? Or, yeah? How many people would consider themselves to be working outside of crypto but interested in what's happening in crypto? Okay, and there's a number of non-committal people. Okay, here we go. Is there a clicker for like changing slides? Thank you. Hey, thanks, thank you. Okay, so I'm Dominic. I founded the DFINITY Foundation, which is headquartered in Zurich, not Zug. And we have research centers in Zurich, Palo Alto, and San Francisco. And the project is developing a protocol called ICP, or Internet Computer Protocol. Does it work? Maybe you can do it manually. Just go next. Here you go. So the purpose of ICP and the internet computer generally is to enable the internet natively to host software with superpowers. And we'll look at what that means. So, hold on. Okay, so we're missing a slide. We got rid of 2 slides. I'll talk about it anyways. So today, the internet is what might be described as a thin internet. It only does connectivity. So there's a base protocol called IP, Internet Protocol, and this allows many thousands of proprietary private networks to connect together to create a single public network, which is the internet, an internetwork. And the interesting thing about the internet is you can use it without any knowledge of the private networks that compose it, that it's composed from. So I can be on one side of the world, you can be on the other side of the world, and we can both be running some software that sends data, messages back and forth, although it only knows about the relative addresses of the computers involved. So if I know your computer's address, and I know which port your software is listening on, I can send it a message. And I don't need to know anything about the private networks that my message will travel over. And generally speaking, if you do a trace route, you'll see there's, probably 10 different networks that your message passes over in such a situation. But the internet's an abstract network. It's a public resource in which computers are identified by an address with, composed of 4 numbers, and software listens on some port. And we don't need to know anything about the private networks that compose the internet. So the ICP protocol will create a thick internet and essentially will be used by independent data centers to add serverless cloud functionality to the internet. So the internet provides its functionality by connecting up lots of private networks. And of course, Internet as a service is created by internet service providers, but there's many other companies involved, transit providers like Level 3, Cogent, Global Crossing, and so on. But this decentralized open protocol combines all these private networks to create the public internet. And there was a time when people thought that was sounded like some kind of sci-fi concept, but today we accept the internet as a sort of fundamental element of the modern world and as essential as water. So in some ways, the Internet Computer Protocol is simpler to understand. It combines computers run by independent data centers to create a single open serverless cloud. So you can think about it becoming moving from being a thin internet, which just does connectivity, to a thick internet, which also will host software systems and data, a bit like an operating system. What's fascinating is it will not only host private software systems, but also open versions of internet services. So the serverless cloud that's produced by the ICP protocol, of course, has very different properties to the proprietary infrastructures that we're used to today that are provided by people like Amazon Web Services. And as we'll see in a moment, it sort of reinvents software to some degree, but it also, as well as sort of reinventing how software runs and the environment in which it executes, also supports new kinds of software, including autonomous software. And we think autonomous software which isn't owned by any organization or person, and which is updated and controlled by tokenized governance systems, provide a new way to create internet services with a variety of advantages. Namely, for example, that they're more trustworthy, and you can build on them more easily. So one of the hidden problems in Silicon Valley is this thing called platform risk, where you want to build on top of someone's platform, but then they take your API away. They revoke your API access. So an early example of that, of course, would have been Zynga. Back in 2012, they built on top of Facebook. They became a very successful games company. They IPO'd. They were worth more than $10 billion. And then Facebook changed the rules. A few weeks later, Zynga had lost 85% of its value. A few years ago, LinkedIn revoked hundreds of startups' API access. All these startups that were incorporating business profiles from LinkedIn into their own services had a big problem. So we aim to fix that with functionality that enables people to guarantee API access can't be revoked. So the internet is at a kind of inflection point, I believe, and the sort of arc of tech history indicates that people prefer open systems to closed systems, and we saw this in the 1990s. We had closed networks like America Online and CompuServe, and Bill Gates from Microsoft was lobbying the American government to create the information superhighway. And thank God it didn't happen. Can you imagine if the internet was owned by Microsoft? It wouldn't be the internet, right? It would be something. It would be an abomination. The world would have gone down a different path. But meanwhile, of course, our critical infrastructure remains owned by big tech, and we want to see this reinvented. Not just the foundational layer. We want to see the internet, the open internet itself, hosting the software systems and internet services of tomorrow. But we also want to see systems like LinkedIn re-engineered in open form using autonomous software. So people often ask, is the internet computer just about creating open cloud hosting functionality? And it's actually about much more than that. We sort of reimagine software. Naturally, the platform's hack-proof. You can build hack-proof software on top. So we address the security issues of today by providing people with a hack-proof, tamper-proof platform upon which they can create hack-proof systems rather than asking them just to buy more firewalls and VPNs and hire more security administrators. We aim to simplify the development of software and internet services and, of course, support autonomous software. There's a bunch of superpowers we like to talk about. There are about 10 of them. And if you're interested in these, the DFINITY team, we've got one of the best teams in tech, and I don't just mean in crypto, but I mean generally. Come to DFINITY meetup tonight. We'll be doing another demo, similar demo that we gave in New York about a month ago. And you can see some sort of powerful applications that have been developed for the internet computer using a new language developed by the creator of WebAssembly. OK, thank you.